Bonjour à tous, merci beaucoup de votre présence. Je vous invite...
Good morning, to take your seats so we can start.
Tous, donc...
Good morning, everybody. Thanks very much for attending this seminar on the role of European agricultural system by 2050. Let me introduce Guy Richard, who's the head of DEPE, Direction of Collective Scientific Expertise, Perspective and Studies of INRAE. Thank you, good morning, and welcome. This DEP at INRAE organizes prospective efforts in response to requests from external sponsors, government departments, AFB, AFD, and agricultural organizations. And this is the case today. This study was done at the request of Pluriagri. This study is part of a series of efforts that INRAE has endeavored 15 years ago through prospective exercises. Agrimonde with CIRAD, that was taken over by Agrimonde Terrain, then a study about North Africa and the Middle East, about food security in that area. And today, with this work on agricultural systems by 2050, we're going to focus on Europe. Thanks very much. You're going to see that the results are very interesting and raise many, many questions.
Donc la place des agriculteurs.
So the role of agricultural systems in Europe by 2050. So this is a far benchmark. There are many, many parameters to take into account. INRAE took up the challenge. INRAE is the product of a merger between INRA and IIASA, which is a National Institute of Research for Agriculture, Food and the Environment. This work is very original for several reasons. First, we have a very thin mesh. We divided the world in 21 regions, and just Europe was divided in 20 agricultural regions. And our conclusions are very interesting. One of them is based on the assumptions that we use for this study. There could be surpluses of farmland in Europe by 2050. So these conclusions will be presented, our methodology too, and we will have a discussion between stakeholders and specialists of the issues and specialists of prospective exercises. And there will also be different stakeholders of the food industry, agriculture industry, and the environment. So people from various horizons. My name is Paul Debrem. I moderate scientific and technical events, and I'm delighted to be here today with you. After Guy Richard, we will welcome the chairman of this association who who wanted this study to be taken away. Pluriagri, the chairman of Pluriagri. Let's give him a big round of welcome, Thierry Henné.
Mesdames, Messieurs.
Ladies and gentlemen, dear friends, I'm delighted to open this seminar on behalf of Pluriagri and to see that you came in such large numbers at the invitation of our partner, INRAE. Pluriagri is an association gathering companies and organizations of the major crops, Unigrain for cereal, for grain. There's Crédit Agricole and say for sugar beets. So our mission is to analyze large crops in Europe and to carry out prospective exercises on markets and the agriculture in the world. So prospective is what we're going to work on today. This isn't the first time we have such an exercise with INRA, well, former INRA, whom I really want to thank for the quality of our multiple collaborations. In 2015, we had worked together to assess food dependency of the MENA area. This had been a fascinating exercise, and then judging by the many feedbacks, it was high quality work. However, the results were cause for concern, especially for a region that is whose population is expanding and which is affected by poverty, and its future is potent for Europe with migrations and political instability. This study showed how climate change could worsen their already preoccupying food dependency. And in 2015, climate change issues got more momentum, and this question is topical on both sides of the Mediterranean. Droughts, floods, very large temperature differences, and even though some scientists are still discussing, or still the jury is still out on the link between these events and climate change, clearly we cannot overlook the importance of this change, this structural and long-lasting change in the environment. Therefore, it was natural that Pluriagri worked on this and asked INRAE to assess this challenge, its consequences on agricultural food systems in Europe, and its consequences for the agricultural community and public policies. Clearly, this work opens avenues that we will have to follow. We will need to determine how French agricultural systems or the different sectors of our country will be able to adapt to climate change and to find solutions to mitigate this change without affecting their competitivity or food security at global level. Large crops producers, oil seeds and sugar beets and ethanol have embarked on an approach to obtain the low carbon certificate or label. This label will allow large crop producers to take part of projects to offset greenhouse gas emissions. This study will also supply useful inputs for the future PAC that clearly has to do with climate change. The agricultural industry is very rarely involved in such exercises, and it's very rare to have them share results and discuss them. And this is why this effort has been so original. That's not to say that we always agree on the interpretation of the scenarios or their application. We're here to debate, and it's it can be expected to have an open or sometimes contradictory debate. But we share the desire to discuss together to find how we can improve the future for farmers and for agriculture, and that gets the best of their contribution. Thank you again for attending this meeting, and I wish you an excellent day of debate.
Merci beaucoup, Monsieur Lenné. Alors, on va bien sûr procéder.
Thank you very much, Mr. Lenné. And of course, now we're going to enter into the gist of things, explain our methodology, how the study came about. And of course, you'll be able, you'll have an opportunity to put questions to the experts, the engineers who designed the studies. And you will be able to use an app, slido.com. So if you look on your phone, if you look up slido.com, you'll see it's very user-friendly. A window will open, there will be a hashtag, and there, all you need to do is to type in 2050, 2050, and then you will be able to enter the space of this colloquium. You can register with your name or your surname, and this will actually allow us to have your questions, to look at the questions. This will be particularly useful if there are too many of them. Slido.com. And now I'm going to ask our panelists, Annette Bérard, Agneta Fauchelon, Bertrand Schmidt, Philippe Debac, Hervé Guillaumard, and Philippe Faverdin to come on stage.
Installez-vous, je vous en prie. Prenez-le. Quelques applaudissements, s'il vous plaît, quelques remerciements. Ah oui.
Please give them a warm welcome. Thank you. So they're all engineers, researchers at INRAE. They have all contributed to the study. Let's start with Anaïs Tibi. You are the coordinator of this study, and you are an engineer within the DEPE at INRAE. I think I'll need the extra step in order to reach the microphone. Yeah, that's good. So I'm not Eric Lenné, that much is sure. Good morning, everyone. Now, the results will be presented in 2 steps. I'm in charge of the first step. I will give you all the elements of the puzzles that allowed us to design scenarios, and then there will be a Q&A session, and then we'll have a second step where we look at the consequences of the scenarios under consideration. So I'm going to talk about the methodology, and then we'll explain how we use our variables for the systems under observation for 2050, and then finally we'll introduce the scenarios that we have designed, scenarios whose impact will be examined later on. So, first of all, what was the aim of this study? It's already been said, but let me repeat it. What we have looked at is food security and what place Europe might be playing within food supply. Of course, we started with existing studies. Here you have a number of them on the screen. We also want to take into account the diversity of European agricultural systems. Europe has been taken into account as a single region, or usually it is taken into account as a single region, and here we have looked at differences. Now, another thing that was really important was to look at the impact of climate change on agriculture, on farming. So we know that the impact as far as the changes for plants and animals are concerned are well known, but what is really difficult is to assess quantitatively the impact. So there's not enough research on it yet, and so we tried to make a guesstimate. And then, of course, there are changes, technical changes, progress in genetics, changes that bring about innovation in agricultural practice. Guy has mentioned it. This study has been carried out by the DEPE, the prospective department. We organized ourselves in 3 poles. There was a project pole, team. Here you have a portrait of some of the participants. Then there was a coordinating team, methodologically and scientifically. So this team was in charge of organizing the conference. And then there's the interpretation of the scenarios, the fleshing out of the scenarios, as it were. And here we have a team comprised of scientific experts. Their role was to analyze the existing literature, everything to do with climate change, and then finally a fourth team from so two members, two experts, and a number of practitioners who had an input on the consequences of the different scenarios, and they took part in the final discussions. Now, the deliverables. You have been able to look at the summary in 12 pages. This is the most synthetic version, but of course there is the full document as well, and this is going to be published online in the next couple of days. And then there's also a specific document regarding methodology and how the existing literature was taken into account and analyzed. This will be available online on the site of INRAE. So, what methodology did we choose? It was similar to the methodology chosen before in a variety of studies, and so we equalize agricultural resources and the use that is made of those same resources in all main regions of the world and also on a global scale. So we used a model of called Pluriagri 2050. Now this model has been designed within the work carried out by CIRAD and the INRAE during the study INRA and CIRAD. And then you can see that Europe has been singled out and that Europe itself has been divided in several entities. Now, let me dwell on this a little while, because you will see what the variables are and also what the initial variables are, those on which we worked for the 2050 perspectives. Regarding the use of agricultural products, three main uses have been singled out. Of course, feeding humans is one, and there we took into account demographics and also the current trends. Then there's animal feed. This is an exit variable that is dependent on the variables related to human food use, and then variables linked to the chemistry, etc., and others. We won't talk about that into too much detail. Now, regarding crop production or vegetable production, there is the type of vegetable, the cultivated area, and variables during a season. You can have several harvests, for example, and then you will have greater cultural intensity. The model will make an estimate of the areas under cultivation, taking also into account the two other factors. Now, regarding animal farming, we have produced coefficients called animal coefficient, which relates to the ability of animals to use animal feed, their productivity, as it were. And then we also looked at the surface areas that could be under cultivation. So we have a low figure and a high figure, and there we reach a ceiling beyond which we know that cultivated areas cannot expand anymore. This is an initial variable. Now, I'm going to explain what principles have been used in order to make a projection for 2050. Now, our starting point is 2010. So actually 2010 is an average derived from 2010, 2011. The scenarios are tendential. Now, this is something important. So we have a starting hypothesis, and our starting hypothesis is that in 2050 we will be in a world where there hasn't been no major economic and political disruption. We didn't take into account any disruption regarding agricultural systems, and so we assumed that there would be the same in 2050 as there are now, at least that the balance between dominant agricultural systems and others would be the same. And then we didn't just project into 2050, but we also make some adjustments, and we took into account the climate change variables. I'll go into more detail later on. And then one key point of the study is, of course, its relation to climate change. Now, since we have this tendential methodology, we assumed that nothing would change, or that greenhouse gas emissions would not be capped, and so that will tell you what happens, what the variables are regarding CO2 between 2030 and 2050. You can see that in this scenario there is a concentration of about plus 22% compared to 2010, and an annual temperature of 1 degree, an extra degree compared to today's temperatures. Now I'm going to go into the detail of the projection of the variables. This is where our work went the most in depth. So I'm going to start with the demand for human feed or human food in 2015. Now, demographics and diets were both taken into account. Regarding demographics, we used the average projections established by the UN, and according to those, the population will grow by 40% compared to 2010, which means that there will be 9.5 billion human beings on Earth. An interesting fact is that there will be a stagnation of the population in China, 1.4 billion, which means that the increase in population will be due to India and the rest of Asia. India and the rest of Asia will be home to another 840 million human beings. And then, of course, Sub-Saharan Africa, where an increase of plus 56% by 2050 is expected. Let's assume that Europe now as a whole, the population should stagnate around 535 million inhabitants, but this actually is not homogeneous. In orange, you will see that there is a slight increase of the population by 2050, so France, the UK, and the rest of Europe, so Ireland and Benelux. On the other hand, there will be other parts of Europe where the demographics will be negative, in Poland, in Eastern Europe, minus 20%, and then Southern Europe, where there will be also a downward trend, albeit a smaller one. Then, regarding diets, there is the total number of calories taken by each person, and then there is the agricultural contribution. Now, we based ourselves on available calories, not on calories that have been used. That means that we include a number of calories that are lost, household waste, etc. And then there are health issues that are linked to food habits and diets, and there we had two hypotheses. In order to test the effects on the need for agricultural supply, we took this into account. So, I talked about trends by 2050. So here we based ourselves on a change. In order to take into account change in diets, we based ourselves on work produced by the FAO in 2012. According to this hypothesis, in Europe and in other advanced regions, but also in the MENA region, the calorie supply will be stable and there will be no change in diets. However, in other regions, there will be an increase in the supply of calories, but not based on the same determinants. Now, in the regions that you have here on the screen, where food transition is already advanced, the increase of total calorie supply will be due mostly to increased consumption of meat, sugar and oils, vegetable oils. But in other regions, transition has not started yet, which means that crops will continue to play a role in the increase, just as oilseeds. That means that there will still be low meat consumption in sub-Saharan Africa, and in Eastern Central Africa, the carrying need will still not be met. The demand will not be met. This is something that you can see on the charts to the right. So here, regional differences will be the same by 2050. Now, second disruption has been considered. So better diets that are complying more with the WHO recommendations, and here we based ourselves on the LC scenario. The first element is that there is a regional convergence between carry supply, 2250 to 3000. You can see this on the chart to the right, and this is a great difference to the previous scenario. In this scenario, Africa is able to catch up. Now, the diet is more balanced and healthier than in 2010. In order to use this diet, we imply disruption in a number of regions. So in Europe and other developed regions, in Brazil and Argentina, it means that meat, oils and sugar are diminishing, whereas in other regions, such as India, there is an increase of meat and animal-derived products. So there's still great disparity between regions, but regional specificities stay stable. So it is convergence, not an eradication of differences between regions. Now, if we look at these two diet scenarios and demographics, what is the outcome? So here we have billions of kilocalories. So by 2050, we will have an increase of 50% of calorie demand, explained mostly by the change in demographics. Now, the change in demand will be based mostly on the sub-Saharan African region and Asia, plus India. So by 2050, 50% of the food demand in the world will actually rest on the shoulders of Asian countries. There will be also strong demand in MENA and North Africa, and in former USSR and in Europe, there will be stagnation. But again, Europe is not that homogeneous. You can see differences between different parts of Europe reflecting demographic change in this region. Now, if we look at healthy diets, compared to 2010, there will be an increase in demand. There will be a smaller demand of agricultural products, and in Canada and the United States, there will even be stagnation compared to 2010. So demographics are compensated in North America, Mexico accepted, by a healthier diet. And in China, there is even a decrease. Now, the main exception in this chart is one region. There is an increase of food demand because of healthy diets, simply because tendential diets are less linked to healthy diets. Now, I'm going to give the floor to my colleagues, and they will talk to you about vegetable productivity. Hervé, the floor is yours.
Hervé Guillaumard, vous êtes copilote.
Hervé Guillaumard, you're the co-lead of this study. You specialize in agricultural economy and market specialization. Thank you. guess who I represent on this comic strip. So now we will focus on supply following Anaïs' presentation. And we will take a look at how we proceeded to project yields by 2050. There are a number of yield graphs that explain what we attempted. So this is a yield curve. There are the input, intermediary consumption, capital on the x-axis. Yields is the y-axis, and the point is matches the use of inputs and the yield. It's a very simple graph. We projected these yields by factoring in a number of facts, of data. The first parameter is how the inputs are used and the increase of their use by 2050. If you increase in this region there, on the same production function, you will have an increased yield. Then we will factoring technical change, which translates in two fundamental mechanisms. Both you will be more efficient in the way inputs are used, so this will increase yields, and you will have breeding advances that will also increase yields, everything else being equal. So there are two things at play, the increase in the use of inputs and technical progress. But there's a lot of uncertainty on what's going on how inputs are used, and there's uncertainty around technical progress. So the first factor we took into account was technical advances to see how yields behaved by 2050. We had two assumptions, one with moderate pace of technological advance and a more fast pace of technological advance. So this is an aggregate of all crops in all the areas, weighted by in different regions, weighted by the area. In 2009, 2010, and 2011, and the horizons for 2050. And in dark blue, you have fast-paced technological advances that's based on the FAO's projections done in 2012. And there is also a more moderate pace of technical advance based on a more recent FAO study. And there is another factor that will affect yields by 2050, and that is climate change, temperature, rainfall, and CO2 concentration. Based on this model with both paces of technological advances, there is a climate change, the green ranges. We took into account two things. First, the change in rainfall and temperature based on a statistical model to assess the impact on yields of rainfall and temperature between C3 and C4, metabolism, CO2, and photosynthesis. So we did that. And the second thing, we took into account the way in the field, the fertilizing effect of CO2 is used. So the yield, we will look at yields with fast-paced technical pace, and in the low end of the range, moderate technical progress and rainfall and no benefit from CO2. Philippe Debac will present this. Philippe Debac is the co-lead, the scientific co-lead of the study. You are a researcher At INRAE, the AGIR specialized of genotype, environment, and the change of crops with climate change. Good morning. Let's take a look at the known climate values, temperature, rainfall, and CO2 content in the atmosphere. So we all know that temperatures will rise. That's a certainty. And for the extreme temperatures, we will have physiological effects on crops that can be quite detrimental. Rainfall, there will be either too much or too little of it, and that will affect growth and may jeopardize the survival of crops. And the second value, the third variable is the CO2 content of the atmospheric CO2. So this might increase the photosynthetic response of crops with to variable degrees, be it soy, rice, or C4 plants such as maize. So the first uncertainty was on the way fields benefited from the CO2 effect. This will depend on whether the plants have enough water and nitrogen, with some genetic variability that is quite significant but is little known actually. So the CO2 response, around this CO2 response, there's some uncertainty on the actual effect it will have in the field. We will take this into account. So based on what we know of these variables, and based on a number of studies matching yield with the variability of these climate variables, we have created statistical models based on an analysis of a series of studies and literature survey from the past 10 years. Models, experiments, and so on. So we can create models that actually summarize everything we know about these changes. So two models were created, a specific C3 model and a C4 model, because as I said, there are different responses for these C3 and C4. And we looked at the marginal effect of a temperature rise on rainfall and on CO2. On the first line, you see that C3 and C4 plants have lower yields if temperature rises. It's larger for maize than C3 plants. We see that there will be a higher level of rainfall and with a limited effect for C4 plants. And we also see the marginal impact of an increase in CO2 that's more pronounced for C4 than C3 plants than for C4 plants. We also see that the CO2 response is different based on the temperature regime. So it's a fairly realistic model based on what we know about physiological behaviors. Now, these are the first results of C3 crops with variations between 2010 and 2015 based on climate change, with different responses to the CO2 effect. So if we take this into account, we can have increases between +2 and +6% of yields over 40 years. Likewise, if we do not take the CO2 effect into account, yields will be hurt by temperature effects or rainfall effects that will be that would be higher than the CO2 effect. Now, for maize, there is also a trend of yield loss with a CO2 effect that will be less significant, that will not offset temperature changes that could be harmful, potentially. These assessments are pretty consistent with the IPCC report that foresaw about an average of 2% loss in yields per decade. If we summarize what Hervé presented in terms of effects of technical change and climate change, we have a change in yields in 2010 to 2050. So there's a low-high assumption with a moderate pace of technical progress and no CO2 benefit between 14% and 42%. And then there's a high assumption. In both cases, we have increased yields with contrasted results based on different regions. There's between 29 and 95% in the high assumption, and 14 and 42 in the low assumption. So there's for France between 0.4 and 0.7%. We focused also on the cases of the US and Canada with low increases of yields, and Eastern Africa with much higher increases, but from a much lower base. So that's it for the plant yields. Now I will give the floor to Philippe for animal efficiency.
Philippe Faverdin.
Philippe Faverdin, you're a researcher with INRAE in the Pégase unit. You specialize in ruminant systems. I'm the cow here. I will present how we dealt with the efficiency ratio issue for this study. It's a key point because that's the link between the animal product demand and the use of plant resources. These efficiency ratios are the ratio between the consumption of feed to produce 1 kilogram of product, milk or meat. And we also computed it for all animal productions with different methods based on the type of production. I will not present everything here. I will focus on ruminants, for which we used a specific method. Ruminants have a problem. We have less statistical data to assess their consumption. It's based on fodder, and the global statistics are not very good. So we used a new methodology that is based on the IPCC method to compute methane emissions. It's the Tier 2 method that assesses consumption based on the energy needs of animals. And once we know the production, we can deduct the needs, so the associated needs. Another advantage is that it can separate the calculation for milk and for meat, because the milk is only produced for the milk cows that already had a veal, and for meat, and the meat products are affected to the production of meat. There are 3 variables. One is the milk production by animal, and another one that's linked to life weight and the associated growth. It's more difficult to have data for this, but we use the GLIM model of the FAO, and we use for meat, we use a specific growth model based on demography to be sure to be consistent with production. And the third important point is digestibility of food rations. This must be assessed on an annual basis. For grassland, we use the data based on the temperature, and for the rest, we use the ratios that we assessed based on a global assessment of the equilibrium of raw materials. just bovines account for 4.5 billion tons of dry material consumed. However, it's mostly on permanent grassland for meat bovines, and well, for milk cows, there's a higher use of resources on cultivated land. So for the efficiency ratio, you have a table here, or a graph of the efficiency ratio. The milk is on the x-axis, and for meat, it's on the y-axis. So there's a high disparity. It's more variable for ruminants than for other species. In all cases, you can see that efficiency improves with animal productivity. The more milk you produce by milk, the better the efficiency ratio, and the same goes for meat. However, an interesting thing is that for low animal productivity, here you see productivities in terms of milk per cow. And if you look at that, you have a general improvement of efficiency ratio of meat of milk. So the lower the consumption, the better, okay? So there's a gradient here where the improvement in productivity induces an improvement of efficiency. And there's a group of countries with a higher productivity of milk cows, and there seems to be some tension between the two indicators, milk and meat. And so when you have an improvement of meat, you have a deterioration of the ratio for milk. I don't know if France, the countries are, where is France? Because it's very small on the graph. Well, France stands maybe middle of the way, on the middle, slightly above the countries around the developed area, Europe and US. The efficiency for meat is not as good for the others, due to the ratio for milk, and that's due to a fairly high level of specialization in milk cattle. The last challenge was to make a projection to 2050. We first needed to find the necessary bovine population to produce this amount of animal products. So we used projections on diets and demographics. For plant yields, we looked at productivities of an animal in milk and meat. For milk, there is a linear improvement across countries. We continued the trend to 2050, but for meat, we have stable productivities. We projected the trends, but they're a lot more stable. And for fodder productivity, we factored in temperatures, and also the fact that to increase milk productivity, we needed better quality fodder. So the conclusions on impacts between 2010 and 2050 of these efficiency ratios is that we have an improvement across thing for milk that's linked to the improved productivity of cows. All the ratios are below the first bisector line, but for meat, we have the opposite problem. We have a kind of dilemma between milk and meat. When we have more productive meats, we have less meat coming from milk cows. So since we have not changed the ratio of meat, we find worse meat efficiency compared to 2010. Annette, you can take over for now.
Quelques instants, on va avoir un moment.
In a few minutes, there will be a Q&A session with the authors of the study. So please, do go on Slido. Once again, you can enter Slido by typing in 2050, and then we'll have your questions. Now, Annette Bérard, thank you very much for being with us. You're a member of the experts panel. You are an INRAE researcher, and you are an expert of the microbiotics of soils and the climate change-induced stress.
pris le bon sens. Voilà. Donc,
Let me find the right slide. Now, regarding methodology, we based ourselves on the GAES, Global Agroecological Zones, something that has been designed by the ISA and the FAO, and this is the base for determining agricultural potentialities depending on present or future climate, the quality of soil, and the needs for crops and other cultures present or future. Then you get an index, a suitability index of soils. So it's the suitability index in English for each kind of soil, and this allows to classify the different soils. And you can see a map to the right telling you where these different classes are. So for crops, for example. Now, given previous studies, we used this index from 40 as a medium value. Now, using the GAES model, we calculated the potential acreage, and then we exploited the available literature. There is not much actually, and we realized that the data was comparable. So we started comparing what is under cultivation in 2010 and what could be cultivated. Now, for some regions, such as North Africa, Middle East, China, and also Southern Europe, the potential acreage in 2010 are either all under cultivation, or actually some areas are being cultivated that are not potentially viable. On the other hand, a number of regions show a strong potential for acreage, extra acreage, such as Eastern Africa, Southern Africa, and Central Africa. Now, moving on to 2050, with the climate-based tendential scenario, we can see that some regions will lose acreage. This will be due to an increase in temperatures and a decrease in rainfall. We can see that there is still some potential given the situation in 2010, except for some regions. North Africa, for example, Southern Europe, and to a certain extent, Asia. Another outcome is that in other regions, such as the northern regions, based on the GAES portal, we can expect an increase of potential acreage because of the rise of temperatures, which will be beneficial for cultivation. For example, Northern Europe and the former Soviet Union are part of those regions. Now, what conclusion can we draw from all this? There will be an extension of potential acreage by 2015, but there will be strong disparities depending on the region. This being said, the data that is available should be taken with a pinch of salt, because the increase in acreage will mostly be derived from forests, and it means that there will be greater deforestation. We know that deforestation has already had an impact and will have a stronger impact on the quality of soils, and this may be, the situation may even get worse with climate change. By 2050, we will see the effects on climate change on soil quality, but we have considered, based on the GAES portal, that the situation will be stable. Negative effects, adverse effects can be expected for a number of soil parameters. there will be a decrease in soil fertility, there will be erosion, and those adverse phenomena will have a direct impact on cultivation. This has not been taken into account simply because we do not have consolidated data. Regarding the loss of soil quality, it is something that is already a problem. We know that our surfaces are losing quality. We know that soil quality is worsening, but we do not have enough data that would allow us to consolidate it and take it into account in our models. Then one last thing, last caveat, regarding acreage that may be lost due to a rise of sea levels and of urbanization. Again, we do not have enough data in order to take that into account into the model, and this is why you will not find them here. So I hope I gave you a balanced view of what we have produced. Thank you for your attention.
Anaïs, pour la conclusion.
And I give the floor back to Anaïs for the conclusion of the first part.
Voilà. Alors donc bon, là normalement vous êtes incollable sur la projection des surfaces des rendements.
So now you know everything about efficiency, acreage, and yields, and now I'm going to explain how we designed our basis scenario. So, two very different hypotheses regarding the tendential scenario according to the FAO and the other scenario based on INRAE. Then uncertainty regarding technological change and uncertainty regarding climate change. So low yields and high yields if the CO2 effect is playing its full role. Now, every surface for acreage, every surface has been taken into account, and then for other variables that have not been explained in detail, we have had one single hypothesis independently of the scenarios by 2050. So here you have a chart that gives you all, so depending on low yield, high yield, which gives you all the different scenarios. So every time there were 4 scenarios, and you will see them in greater detail later. Then one last slide that will be a teaser for what is going to come after the Q&A. So we're synthesized based on the Global Green model. Agneta will tell you more about it later. The first simulations allowed us to examine the trends in surfaces under cultivation for all regions in the world. Now the first results that we have allowed us to identify the world regions where by 2050 we may see tension regarding the access to soils, and also it singled out the regions where we could see a reduction of surfaces under cultivation, in particular in Europe. Now, that was the first step, and then we also carried out a second step analysis where we looked at the opportunities that would be provided by the reduction of surfaces under cultivation, and there we looked at different European strategies with 2 aims: ensuring food security and also take into account the impacts of climate change and the impact on the environment, for example, outside Europe, or what the impact will be on the dominant agricultural systems in Europe. Now, after carrying out these analyses, we also tried to answer the question what the effect would be of factors that would have an impact on agricultural systems, but that are difficult to assess in a model for 2050 and that have not been taken into account. Thank you very much for your attention. And now we'll have a Q&A session, about 15 minutes, for our first phase of the presentation. Thank you.
Et donc la dernière diapositive va vous montrer ce dont on...
Now, on this last slide, you could see what we're going to talk about later on. Okay, now we have some questions on Slido. How can technical progress make up for the deterioration due to climate change of yields in Europe? If we renounce use efficient tools, how can we cope? Who would like to answer that? The floor is yours. Hervé Guillemard. The questions are anonymous. Am I right? So in Europe, in the different European zones, as well as in the rest of the world, we try to look at trends in yields. I'm going to talk about vegetable farming, not animals. Now, there are three main factors. Now, the entrance that you use, fertilizers, pesticides, and other tools for precision farming. So this has to be taken into account. Then there's technological progress. Now, technological progress is made of two factors. One thing is that farmers will be more efficient tomorrow simply because they have received better training, because the technology will, for example, improve the use of entrance. And then there's progress in the area of genetics. Now, I know that there are some geneticians in the audience, so they will be able to tell us more about how much progress we can make there. So, and then there's a third factor, which is climate change. So, regarding technical progress, we based ourselves on two hypotheses that seemed realistic by 2050. So, one based on moderate technological progress and one more optimistic hypothesis. Now, we base ourselves on a scenario where there will be no major political, economic disruption, where the common agricultural policy will still be around, and where there will be no technological disruption. That means that it will be the same broad environment, and so we extrapolated from what has been observed in the past, making adjustments. And so in order to try and provide an answer to the question on the screen, I am not sure that I agree with the statement at the end, renouncing production tools. I mean, Eric will be able to tell us more. I don't think that practitioners are actually renouncing any tool. What we're trying to do, on the contrary, is to try and reach two objectives, which is to be more efficient while taking better care of the environment. I'm sure that there are questions on the floor. Would you mind passing the microphone? Any questions in the audience? But before we ask the audience on the floor, we have questions. One regarding yields, for yields. So I'm reading out the one in purple. Why not talk about the users? 40% of the surfaces under cultivation are used for animals, others for crops. Bertrand Schmidt, would you like to answer that question? Well, I think that the key point here is the two different diets that we based ourselves on. We have a tendential scenario, which gives us the cap of what we can do, and we based ourselves also on the hypothesis of a healthy diet, such as compliant with the WHO recommendations. So the share animal farming and crop farming will be the same, but we can hope that there will be a decrease in meat consumption or in animal products. Now, in certain regions of the world, animal products is such a small share that it will by necessity increase. This is particularly true of sub-Saharan Africa. You are an INRAE researcher. You specialized in agricultural economics and also of prospective and projections. Someone in the audience? I see a lady who would like to ask a question. Good morning. I'm sorry, my phone is everything but a smartphone, and actually, so I come from the water agency, and I have several comments. Now, my first comment is, you say that the RCP 6.0 is a tendential scenario. Now, we work also with climate experts, and we base ourselves on the 8.5, the RCP 8.5. Now, the ICCP report actually will go beyond RCP 8.5. So we have a climate expert here, and he may be able to answer that.
Est-ce que vous voulez nous... Oui, je vous en prie, monsieur.
Oui, effectivement, tendanciel, comment il faut l'interpréter?
Okay. How can we interpret that? We were basing ourselves on the current scenarios, projecting an increase of 3 to 4% of temperatures. So this projection of 3 to 4 degrees is based on the latest ICCP report. So basically, we are well beyond the PKD 8.5, and there will be a higher increase of temperature. This would mean that for our studies, taking into account uncertainties, we are actually making a low estimate, and so this would actually be close to the cap of the RCD 6.5. So we're using the CPR 8.5, whereas here, yes, it is true, in a study we used another one. Second comment? No, well, complementing the answer. Now, the figures given for temperatures in 2050 are actually those for 2100. Now, the difference between the two models, 6.5 and 8.5, so are the different CPRs, the difference is much smaller when you add 50 years. My second comment. Technological progress is not supposed to be to have an impact on the environment. This goes against what we can actually observe, at least in France. There is clearly an impact on the environment that is due to technological progress. So I was wondering how you could dispense with that hypothesis. Now, regarding yields and agroecology, experts say that so that environmentally friendly farming has positive effects on the environment. And so I was wondering what the effects of technological progress would be. Don't you think that you should have taken into account the feedback of these effects on agriculture itself? For example, loss of biodiversity, something that we can already observe. Why not take into account the tolerance threshold of the planet, for example, regarding nitrates? Well, I'm going to try and answer that.
Il y a un point en préalable, c'est qu'il y a beaucoup de vos questions qui sont sur...
No. Some of the questions you ask now will actually find their answers later on, but I mean, I'm going to try and answer this very relevant question. So, yes, my charts are straight, but I am not actually imagining that it is really going to be a straight line. I'm sure that the graph is going to be more subtle. This is necessary simplification. So what I would ask you to do is not to extrapolate from what has been presented. Now, when we do yield projections, yes, there are entrance, technological progress, and climate change. These are our three key factors in this area. So when you say, depending on the relative weight of these three factors, you will have very different scenarios for the environment. So there will be an impact, for example, on acreage, and there will be an impact also depending on use of areas, depending on whether they're under cultivation or not. And then there's also, yes, that is true, the impact on deforestation, loss of biodiversity, etc. So jumping ahead, one of the conclusions we reached is that there is a need to be able to make a difference between yields in 2050 depending on an increased use of fertilizers or entrants, depending also on possible progress in genetics or on the trends in the environment. Now, this is something where the literature is very hesitant, and of course, the result in 2050 regarding yields for farming and for animal farming will be very different depending on the weight of these factors. Okay, another question. What about the effect of eco-friendly environment in Europe and in the rest of the world? Guillaume? So what we did, and I'm sure that in the audience there are a number of people working on global trends, we have to work on every region in the world. We need data for every region in the world. So you may be surprised that we start from a situation in 2009, 2010, 2011, which is in the past. But we needed to have statistical data for every region of the world. In Europe, of course, we have rich statistical data, which is not the case in other regions of the world. This is why we actually said that there were some inconsistencies regarding animal data. Now, the other point is that we gave up on an analysis based on production systems. So, for example, organic farming, agroecology, forest farming, etc. Now, regarding animals, there are different farming systems, and you need to have something, a model that applies to all regions in the world, which is why we chose an approach based on a product-based approach, which allows us to have greater consistency and greater comparability of regions of the world. And that does not mean that we won't be unable to look later on at the share depending on which agricultural system is used, for example, what the share of organic farming is. Question, André Jean Guerrer, thank you for giving me the floor. You chose the hypothesis of CO2 trend. I didn't hear anything about public policies in France and in Europe aiming at carbon neutrality by 2050. So this study is looking at the marginal price of the CO2 economy with a cost of 600 to 700 euros per ton by 2050. Now, if this price of carbon were taken into account, would it have an effect on the way on agricultural practice and on the balance forest arable land? Answer. Yes, this is a scenario we didn't take into account. That is true. My guess would be that if we took that into account, so in different models, there would be an effect. But yes, I have to admit that we didn't take that into account. The reason for that is that we have based ourselves on tendential scenarios where we do not take into account public policies where there would be a price increase for carbon or other kinds of subventions or support for agriculture. Now, this is deliberate because what we want to see is how what the impact on food security will be, what the effects are on the supply side, and not so much what the effects would be depending on public policies. Well, of course, one could choose other methods and take into account public policies, but so we deliberately left that out. For example, to assume that there will be a common agricultural policy by 2050 is also a guess. I really don't know. And then there are also extreme climate phenomena.
Voilà, si vous voulez lever la main, et on vient jusqu'à vous.
There are extreme weather events. And again, they have not been taken into account. My name is Agnès Gosselin, and I'm work for the French Soil Association. I must say that I am flabbergasted by what I've heard this morning. For the past 10 years, we've heard that we need to reduce fertilizers and pesticides. For the last 10 years, we know that we need to stop deforestation, and I cannot hide my surprise. Every time you decided to turn your back on disruptions, and I think that disruption is actually precisely what is going to happen by 2050. Change is needed, and change might happen in order to protect our communities, to protect our soils, if we do not actually want to hit a wall. Thank you for your question. It's rather somber, so Hervé Guillaumard will try and answer that. Well, clearly, he has to answer for a lot. We certainly do not aim to be able to address all questions. Well, I see a skepticism, but let me develop, please. You're right. Regarding French, European, and world agricultural practice, we must reduce adverse effects on the environment. We must take into account public health issues, and that a lot of work is to be done. INRAE, but also partners, are working on those very questions. But at the same time, what we tried to do was to take into account food security. This was our initial perspective. Which is why we took into account FAO studies. So what would the increase in yield be in order to be able to feed the world population? And so there is a trade-off between the land that's used for cultivation and yields. Now, this was really our framework, and while hoping that there will be an improvement for animal farming efficiency, we wanted to look at the place of European agricultural practice. That is really what we tried to do. We never claimed that there was no need to look at ways of reducing the impact on the environment. Our particular perspective didn't mean being blind to those issues. But if we're looking at the impact in all world regions of more environmentally friendly farming, and also at agricultural practice using fewer fertilizers and pesticides, there it's very difficult to measure yield by 2050. Bertrand Schmidt. Now, use the scenarios that have been produced as scenarios in a world where nothing changes. So if we do not change anything, what will happen? And what will be the effect on world food security if we follow the same trends as are prevalent today? Now, after showing you the results, we will actually make room for possible disruptions, possible changes. So once we will have presented the results, we will be able to look at disruption at a world level. Well, I would ask you then to move on to the second phase. What's going on? Now, a number of questions that have been raised will actually find their answers in the second phase. We will show you the results, the scenario-based results, and we are going to start with Agneta Forslund.
Forslund, vous êtes responsable du volet de modélisation.
You're in charge of the modelization part of the study, and you're an INRAE engineer with the Ecosocial Department. You're specializing in international economics and modelization of global markets. Good morning, everybody. I will briefly explain how we use the Pluriagri by 2050 model that we studied for this survey before giving the floor to Bertrand Schmidt, who will present the results of the reference scenarios. And next, along with Philippe Debac, we will present the existing wiggle room for European agricultural systems by 2050, and Hervé will conclude both parts of our presentation. Thank you, Annelies. So you've looked at this in detail this morning. My colleagues presented each of the key variables of the systems and how we would approach them by 2050. To run this model, we simply added 2 parameters for trade. This is an equilibrium model for agricultural prices, and it doesn't have prices, so it's a fairly simple model. So for trade, we have export market shares that are defined as exports of a product divided by global imports of the same product. We have the import ratios, which are defined as the import of a product but divided by domestic uses of the product. So these parameters are computed for the initial situations and are kept constant in all simulations. And only if a region reaches its constraint of arable land presented by Annette will we alter these parameters. So we will transfer these variables on the following scheme. So the graph. So for the equilibrium balance, we have the basis equation, which is an equilibrium equation. We will first introduce demand shocks, so human demand, other uses, and so on and so forth. The variation of total domestic use will have direct impacts on imports via the import ratios. Global imports will move, so there will be some impact on exports of a product via export market shares, and all of this is going to adjust production. If it's animal production, the model will compute grassland, and via animal efficiency, it will compute animal demand that will impact total domestic use of the model that will in turn move. And we're back, have from some impact on imports and exports. If it's plant production, the cropped acreage would be computed by thanks to the projections we have. So we will move from the crops to acreage via the efficiency ratio that we have projected by 2050. We derive a need of cultivated acreage based on the technical conditions that we have fixed for supply, while keeping for each region this a constant share in global trade. If one region reaches its constraint level of cultivable acreage, there will be impact on exports, so there will be an increase in exports. If that's not enough, the model will increase the imports ratio to increase imports until the region meets its constraints. So this is a model that's very simple to run. It's transparent. It's easier to read the results, and it also enables step-to-step analysis, so we can isolate each variable to assess its impact on the end result. So that's what Bertrand will present right next to me. So let me remind you the reference scenarios. We have 2 contrasted hypotheses on the diets, trend-based and healthy, 2 assumptions for technological pace, progress pace, high and low, and there's a number of other parameters. So we end up with 4 reference parameters: trend-based diets, high yields, and healthy diets, low and high yields. Bertrand, over to you. I dread the next slide. Uh-oh. That's Tintin. Now I will present the results of the simulation. The first part, my colleagues presented the ingredients. Agneta just presented the blender. I put everything in the blender. I put the right temperature, the right speed, and I end up with something. We have to bear in mind that this is not the future, how it will really occur. So if I use the future tense, please mentally make the correction and use the conditional tense. Everything I'm going to say is linked to the fact that we have set technical conditions and diet conditions, and the model will tell us things based on specific conditions. It just says what the world could look like when all these technical conditions are met. And if each region first tries to meet its domestic demand, to keep its import ratio constant, and to keep its market shares, its export market shares. So only under those conditions will everything I'd say be valid. So I'm sorry for this long introduction. Now let us take a look at the change in surfaces under cultivation in the world and in Europe. So I have the 4 scenarios as defined a while ago. First of all, we have a potential significant expansion of areas under cultivation under the low yield assumption. And this is cancelled. This increase of acreage is cancelled if I have a high assumption for yields. So the situation in Europe is the opposite. In Europe, we have a reduction in the need in areas under cultivation under all the hypotheses, and it's all the more marked that diets become healthy. You see the gap between the world and Europe, and if yields are high, so we move up from -3% to -24% compared to 2010 based on the hypothesis used. So this is where what we're going to have to take a closer look. Seems to be a paradox between the two types of results, and we're going to look at this by a step-to-step approach, by decomposing the effects of the various components in different areas in the world. So bear with me now. Now let's take a look at what would happen if we had only, by 2050, only the effects of the demand-based effects, so based on population and trend-based diets. So this is based on the technical conditions prevailing in 2010. So what do we see? We have the change of areas under cultivation that would be tremendous in Africa, sub-Saharan Africa, driven by population change and by diets. It would also be high in India. That's also due to diets and demographic trends. A little less pronounced in Brazil and Argentina. and would be much more limited in the former USSR, China, Europe, Canada, and USA. And this sends us back to what Anaïs was saying. Demographic dynamic is low, and diets are fairly stable there. Now, let's take a look at all the areas in the world and put them on a single axis. So this is the demand effect. And I add the supply effect. So I'm changing the technical conditions, moving from the 2010 conditions to the ones that we designed for 2050. So we expect to see all the dots on the horizontal axis to go down along the vertical axis, because the technical conditions will improve supply, hence reduce the yield needs for each region. So we will bring it down possibly to the second bisector line, which is a cancellation of demand effects by supply effects. All the regions below this will have situations where potential land surpluses, and the regions above this line will have additional needs compared to 2010 in land. So what do we observe? Despite the change in technical conditions that we foresee for some regions, the increase of acreage under cultivation is very significant in Africa, multiplied by 2, very high in India, plus 25%, which means that the improvement in yield is too limited to offset population growth and diet changes. It's much more moderate in Canada, the US, in Brazil, and Argentina, where the yield change do not completely offset the demand effect, but partially. And below this second bisector line, we have the former USSR, Europe, and China, where crop yield change offset the demand change. So in these regions, we will have a potential surplus of acreage under cultivation. So that's the basis scenario, which is trend-based diets and low yields. Now I will move this. I will move to high yield, the high yield assumption. So we will go down along the vertical axis to have a more pronounced effects on supply conditions. So in some regions we'll have a much lower increase of acreage under cultivation in Africa and India, moving down from 240 million to 96 million hectares just through an improvement in crop yields. And we would have higher potential surpluses in the former USSR, Europe, and China, and we would, for Canada and the USA, we would have a potential land surplus for Canada and the US. Now, let's take a look at diets, and we will see move diets up and down. We would like to see why the diet effect at global level is much smaller than the yield effect. What we would expect is to see all regions to move along, towards the left through the improvement of diets. This is what we're seeing across regions, and in this case, we have lower land needs in these regions. It's the case for Europe, China, the former USSR. We have more land surplus. In Canada and US, the need for extra land would give way to a surplus. There would be zero balanced situation in Brazil and Argentina, and a much lower increase in India. And in some regions, we see an opposite trend. They tend to move to the right. It's sub-Saharan areas where we have healthy diets, increasing the need for acreage under cultivation, because that would translate into an increase in needs in caloric. So we would move from a additional use of plus 196 to 234 million hectares. So we see that the diet effect is much smaller. That's not to say that we don't need to improve diets, because to improve diets in Africa, we need to make an effort and to change our own diets. To summarize, the change in acreage under cultivation in 4 scenarios. In sub-Saharan Africa, a very significant need for extra land, which is more pronounced with healthy diets. In India and the rest of Asia, we have less need for land that's with high yields. Now for North Africa and Near East, we're already, as Anya said, we're already blocked because there's no leeway to increase acreage. We will see the consequences later. On the other hand, we have areas where the land constraint becomes looser. We can have actually land surpluses, which is all the more high than the diets are healthy and yields are high. That's the case in the former USSR and Europe. And in Canada and USA, we would have an emergence of land surpluses with healthy diets. And this is a special case of China. Systematically, if you see the previous graph, you have a land surplus. With these changes, we could see a land surplus in China. But we have to remember that China is a very large importer, and the model is based on the situation of the current situation in terms of imports and exports. So there's a paradox with China, because China could reduce its acreage while increasing its imports. You can, so obviously this is impossible. So we will have to treat China as a special case. Now let's take a look at what happens in Europe, because that's our focus today. The land surplus that we see across Europe is unequally distributed across regions in Europe. So we have Eastern Europe, Germany, Poland, and Central Europe, which have low population growth. They will have most of the potential land surplus. And this will all the more pronounce that yields will be high and diets will be healthy. So this could provide a wiggle room of 16 million hectares if we combine both effects. In France, the UK, and the rest of Europe, which have a somewhat higher population growth, and France has had market shares on international markets, could keep them. So the need for the situation could be positive, and healthy diets could also create a small surplus, land surplus. Now, for Southern Europe, we have a special situation. The model would highlight quite significant land surpluses, but however, there's a high import rate, which is kept in the model, and there's some likelihood that the land surpluses would be mobilized to reduce imports. Now let's take a look at the effects of this on yields and imports. So for the production growth in kilocalories per region, so this reflects the change in acreage under cultivation and of yields. So the change in agricultural production will be huge in Africa. It would increase 2- or 3-fold. So that's the impact of demand on acreage and on yield. Even though they stay quite low. Production increase would be significant in India, but contrary to sub-Saharan Africa, it would be smaller with healthy diets. Production growth would be very low in the former USSR. That's the impact of population growth. It's very Russian. A very low change in demand. It would also be very low in Europe, except for France, because France has both the demographic effect and the maintenance of its export position, which is quite closer to what we see in Canada, US, Brazil, and Argentina. Now, for trade, the model works quite mechanically, so the results could be expected. We have a reinforcement of current positions on the international markets. You have on the one side Europe and on the right the rest of the world. So the net export positions in 2010 would be reinforced. Rest of the world, USA, Canada, and Brazil, Argentina. And this would be attenuated with healthy diets. The net import position would be reinforced for France and Eastern Europe, joined by Germany, Poland, and Central Europe, which would become net exporters as we run the various scenarios. On the other hand, we would have a reinforcement as a result of the blocking of acreage. More imports in North Africa and the Middle East, and also in sub-Saharan Africa, we would have more acreage under cultivation, more production, and despite that, we have to increase imports to feed all the population. Two special cases that I won't dwell on too much, but I mentioned a while ago: China on the one side and Southern Europe. We can discuss more on China later. So at the end of the day, we have very contrasted behaviors across the world. And you have to bear in mind that this is very consistent with the rest of international literature. The change in acreage under cultivation is in expected ranges across the literature. Some of the differences that we see between regions have to do with the way the model works, which is preserving the position of regions in the on global trade. So we would have a high level of increase of demand in sub-Saharan Africa, with an increase in acreage under cultivation, an increase in cultivation, an increase in imports, all of this being accentuated by healthy diets. In India, all of this will be less attenuated also with healthy diets. In North Africa, where there is a constraint on arable land, we would have a very significant increase in imports. We would move up to 70% import rate for these North Africa and Middle East. For Brazil and Argentina, we would have an increase in surface production and imports that has to do with higher domestic demand, but also a higher demand on imports. So this the change would be very attenuated with healthy diets. On the other hand, in some areas, there could be potentially land surpluses. The former USSR, which is a very low population growth, there could be a decrease in surfaces, and it could be the same in the US and Canada if they move to adopted healthy diets. And in Eastern Europe, Poland, and Germany and Central Europe, it could be the same. And it would also be the same for France if France adopted healthier diets. There's a special case of China and Southern Europe, where there would be a decrease in acreage under cultivation despite high imports. Now let's take a look at what could be done. What wiggle room do we have for European agricultural systems?
Anita Forschlund.
Alors, donc dans cette partie, on va essayer de...
Now, in this part, we're going to see what the room is for maneuver for European agricultures by 2050. We're going to base ourselves on our 4 base scenarios. And we're going to see what margin there is in order to optimize the strategy for using the surplus of arable land. So what you can see is that the surplus of arable land could, in a scenario where with low yields, be around 2 million hectares and 13 million hectares with high yields. Now there are disparities within the European region with Eastern Europe, Poland and Germany, the greatest contributors in range of 80% to the surplus, whereas France, the UK and the rest of Europe have a very small land surplus, and only if there is a healthy diet. Now, Southern Europe is not taken into account in this land surplus because we consider that this region is going to use its arable land in order to reduce their imports. Now, first example, produce soy and reduce soy cake dependency in Europe. This is really a particular example, but we use this for proteaginous products as well as oilseed products. Now, the regions, the European regions would be France, Germany, Poland, Central and Eastern Europe, but we didn't take into account the United Kingdom and the rest of Europe for climate reasons. So we based ourselves on a low yield scenario based on the yields in 2010, and for the high yields we based ourselves on the projection by 2050 for France, 3.3 tons per hectare, and then we estimated the possible reduction of total imports of soy cakes for each scenario. And then we also calculated what the European contribution could be to a slowdown of the expansion of soy farming in Brazil, Argentina. So, here you have the impact on oil cake European imports. So there would be a reduction in soy cake imports because there would be smaller consumption of animal products. And you have the figures on the screen. So the figures range around 54, 53%. Then you have the calculation after reduction of land surplus. Now, in the case of healthy diets, we can see that the imports could diminish by half with low yields. Now, with high yields, it would be possible for Europe to produce much more soy and soy cakes on land surplus, which would allow to stop imports to Europe, and Europe could even become a net exporter. Dependency would go down to 0%, and we would still be able to have land surplus for other years up to 9 million hectares if there is a healthy diet and a high yield. So what does that mean for Brazil and Argentina? So here the impact would be felt for 1.5 million hectares, up to 10 for high yields. Now, there's a second example that we would like to highlight. What could the situation be if we have reduced use of fertilizers and pesticides? So therefore, the idea would be to use all of the land surplus in order to see what the result would be by region. So this is a trend towards less intensive agricultural practice, and there we try to calculate the yield in 2050. So of course here the applicable scenario is low yield. So this is a scenario where all land surplus is used, where yields are stable, and we compared this potential yield with in the different scenarios and compared it to the situation in 2010. Now, what you have here is the trend of average yields compared to 2010 in percentage. Now, I'm not going to comment each figure, but if you look just at the European average, in your low yield scenario, there would be an increase by 15%, and if there's a healthy diet on top of that, it would be 19%. So if we use all of the land surplus, what can be seen is that an increase in yield would be possible for 3 regions compared to 2010. Now, the 3 regions are Eastern Europe, Poland, and Germany. Basically, those countries where there's the greatest land surplus. The other regions, not having land surplus, would not see an increase in yield. Now, with healthy diets for these 3 zones, an increase is possible for Eastern Europe, Germany and Central and Poland, and we would see a lower increase in yield for other zones such as France, UK and Central Europe. There's one region where there's no change because there's simply not enough land surplus and there's no room for increase. Now the average in Europe, so the yield could increase by 13% in tendential scenarios, up to 15% compared to 2010, and if there's a healthy diet, the increase could be 12%, whereas it would reach 19% in case of healthy diets. To summarize, by 2050, and without giving up its part on international markets, because we have constant trade parameters using the scenarios, there would be room for improvement in Europe to optimize its agriculture. It would be possible mostly in Eastern Europe, Poland and Germany, slightly less in Central Europe, whereas France, the United Kingdom and the rest of Europe would have less room to change things. And depending on high yields and healthy diet, there would be even more room for improvement. Now, this would be a potentially win-win situation, but we didn't take into account policies, and we did not take into account the availability and access to water. And Philippe Debac, my colleague Philippe Debac, is now going to talk about the use of water in agriculture. Philippe Debac, you have the floor. So we considered that the yields that we calculated were not taken into account the reduction of water by 2050 either, because there is a degradation of the access to the resource, or because of smaller rainfall. So we base ourselves on a yearly average, not on a rainfall average during the period of growth, and we also did not take into account the lack of water for crops such as maize and summer. Now, we assumed that in the study that there would be the same amount of water available between 2010 and 2050, despite knowing that actually this is not very likely. But there is no data that would allow us to make projections that are scientifically viable. So we imagined different yields depending on a reduction of water availability, so with smaller irrigation and lower rainfall. Taking into account what climate experts tell us regarding the access to water, there is uncertainty, but in Europe, one can make an estimate of a significant reduction of rainfall, in particular for France, Southern Europe, Eastern Europe, and Central Europe. And now, in particular, during the growth phase of crops, there would be a decrease, a significant decrease, especially for those crops cultivated during the summer. It would be less marked for less significant for winter, but even in winter, a country like France would see reduced water rainfall. So we consider that this could allow us to calculate what the satisfying level would be as a proxy and what the constraints would be on the rain-dependent crops. We assumed that there would be then the access to, or that the surface area that is being irrigated would be divided by 2, and so that in Europe the average would go down from 8% to 5%. This will, of course, have an impact on the yield. We have taken the example of wheat and maize. You see that this means a decrease of minus 15% for Southern Europe, minus 10% for France, minus 7% for Eastern Europe, and minus 4% for Central Europe. So we had a new set of values for yields, and this is the change that the impact on the model that has been presented by Agneta. You can see that for the whole of Europe, on a trend-based model, there is a reduction of arable land or of acreage under cultivation. So, in our view, the water constraints have a real impact. Now, in Southern Europe, there is also the lack of land surplus and the need to reduce its imports. Whereas for France, for example, the trade balance is better. I'm now going to give the floor to Hervé Guillaumard.
Alors, j'ai le beau bouquet.
Right, I'm the last one standing before you in lunch, except for the Q&As. So I'm going to try and give you the overview of the main lessons drawn, highlighting the uncertainties while trying to avoid to rank the scenario or give you a list. But let me start with a caveat. We have tried, and Bertrand said it, to describe, to be very descriptive. It doesn't mean, of course, that there weren't any normative biases, but we see a need to move towards healthier diets because some parts of the world population is overfed while there is still malnutrition in other parts. And then the second caveat, which is important, and that was also something I started saying when answering a question. The projection is for 2050, so we also looked at a severe deterioration by 2050. And when we compare the trend-based scenario and the aggravated scenario, we do not see a great difference. And at the end of the day, what we see is that the impact of climate change by 2050 is actually smaller than the impact of technological change. And now, I'm not saying that 50 years later, by 2100, this will be the same thing. So really, lots of caveats that I could actually add, but these are the two main ones to keep in mind. So the first the point that Bertrand mentioned is about land surplus. The main lesson here is that if there is no technological change, our need in arable land will be too high. 60 million hectares could be necessary in order to satisfy demand, even if there is no major trend towards a healthy diet. And then there would be a surplus in the former Soviet Union, in some of Europe and Canada, United States, whereas there would be extra demand in the MENA region, Africa and Asia, except for China, which is a particular case. So the better technological change, the higher the yield. So, for example, in the United States and Canada, and there would be also a decrease in demand. Now, in the case of healthy diets, it would mean an increase in land surplus. However, regarding needs, this would not apply, and Bertrand drew your attention on some of the African regions, which would be an exception. So basically Sub-Saharan Africa and the tip of the continent, South Africa. Now, you have also a variety of situations in the different parts of Europe. The European Union is a comparatively small zone, but again, there is a contrast with a decrease of the need for land in Eastern Europe and in Poland, to some extent in Germany and in Central Europe, and demographics here play definitely a role. Now, you saw a chart pertaining to demographics, and there's also the trend towards other diets. So, given that situation, when we talk about arable land in Europe, we always need to take into account demographic data, which of course raises the question that if we are wrong with our demographic data, then the situation would be different. Yes, that's true, then we'd have different scenarios. The situation is not the same in France, the United Kingdom, and other parts of Europe. And then there's Southern Europe that would be in a similar situation to China. Then there is also the case of permanent land grassland. Now, in our scenario, we took into account an increase in the surface dedicated to grassland, and thus may not be sustainable and raises the question of animal farming efficiency. Now, regarding the need in arable land, there will be an effect on global trade. Now, once again, we had parameters, we used stable parameters, but this may be able to change. So what you may have is a polarization, an increased polarization of agricultural trade, with exportations exports from North America, Latin America, the former Soviet Union and Europe, and net imports from the MENA region, Africa and Asia. Now, final lesson, the use of land surplus. We talked about it at length. Now I'm going to try and wrap up quickly. So we looked at the way how we can, what we can do regarding oilseed production. So there would be two benefits. For example, a reduction of the import of soy cake to Europe, which means less deforestation in Latin America, and also a desintensification, lesser intensity for European agricultural practice, meaning that the yields would slow down by 2050, given what can be done with surplus land. Now, in this slide, I'm going to take into account what's some of the questions that have been asked between our two phases. So, given the method that we have used and that we have developed, we have taken into account incremental adaptation, so marginal adjustment, but we didn't take into account systemic adjustment or disruptive transformational. It's not that we do not want to do it, but we want to be able to compare what is comparable all over the world. Now, the impact on systemic adaptation it cannot be measured on the on animal farming efficiency and crop farming. We do not take into account, for example, on genetics or breeding, because this actually may able to adapt. And then there are the extreme weather events. Now, my yield ceiling and low yield scenario may be able to take into account climate change parameters from year to year. So, for example, in a given zone, what is actually the high yield could be the low yield and vice versa. But what we didn't do is actually to take into account repeated shocks in case of extreme weather events year after year. Now, we cannot measure the cumulative effect because we don't know how farmers would adjust. And then there's also the question of pests and of plant disease. Now, pests. So what we did here is that we made the hypothesis that the effect of pests on the growing of crops would be the same as in the past. Now, the big question here is, will the change in environment change the impact of pests on cultures or not? Now, it's not that we did not want to take it into account, but again, we wanted to avoid to compare pears and apples, and so we decided to leave that out. Now, the question of pests is something that would require further work. And then, this last couple of months, or this last couple of years, the question has been raised of the impact of climate change on the quality of products. Of course, a nutritional composition and the presence of micronutrients is changing due to climate change. This we didn't take into account. We would need to modelize this, but again, it will be very difficult to do anything that is scientifically meaningful if we want to look at the whole world. This is why we focused on a number of points. I mean, of course, scientists are always going on about data, but it is important. I think that there is a need to insist on the fact that the yield of arable land is maybe not the key issue. We need to actually look at other things. So, for example, the animal feed, production of animal feed, animal efficiency. Now, this is fundamental if we want to have efficient models. And then there's also, of course, the arable intensity, so the relationship between harvest and acreage. Then there's irrigation, surface and yields. And finally, there is the question of potential acreage and the measure and impact of climate change and how it can be taken into account in a way that is consistent across the world. Now, regarding climate change, there is the effect of CO2 and whether it's going, how beneficial it is going to be. Then there's also the question of how pertinent our equations are for the C3 and C4 plants. Maize is a particularly good example. And then finally, there's the interaction between climate parameters and the adjustment to climate change. Now, regarding the second point, technical change, there will be the changes in fertilizers and pesticides, and it is the relative weight of all these factors that will have environmental impacts as well as impacts on public health. So this requires a lot of extra work. Final slide. Of course, we need to take into account the impact on the sustainability of performance. Now, when you add modules regarding the environment or public health, you change your model. I mean, it is very difficult, but you can add a module without changing the whole method or the whole methodology of the model. Now, the economy here is a blind spot because that would require definitely a change of approach. And this is why public policies and prices are not taken into account, even if they have a huge impact on how practitioners behave. And then finally, there's a list of uncertainties. There is the biotic stress. That would, again, require different modelization. Then there is the nutritional quality of products. This would require further simulations, and then there is the question of the water availability and the impact it is going to have on the yields in relation to arable surfaces. Thank you very much for your attention.
Merci beaucoup, Hervé Guillaume. Revenez avec nous.
Thank you very much, and I hope that we will have now a few questions. Yes, here they are. I see a 10th question. What about the impact of these scenarios on greenhouse gas emissions? Agriculture at this stage is responsible for 20% of greenhouse gas emissions.
Schmidt.
Bertrand Schmidt, would you like to answer this one? So we do not have a specific model for greenhouse gas emissions, but we are able to make calculations depending on diets, because here there is available data. Now, if we look at the global impact on the trend-based model, but this is not taking into account trends in arable land and also assuming there's no change in agricultural practice. So I'm talking only about diets here. Now, the trend-based model would carry with it an increase of 40%, and if we switch to a healthy diet, the increase would only be 5%. Now, we also need to take into account the change of use of grassland, so the change of use in land, and also the changes that would be brought by different agricultural practices. So plus 5% or plus 40%. If I may complement, now regarding the change in agricultural practice, and this is an answer that we have made several times, if there is technological change due to different kinds of fertilizers, pesticides, with an effect on greenhouse gases, there will be a strong increase. However, if it is just a matter of better breeding or better additives, then there will be lower greenhouse gas emissions. But what we cannot do in the current model is to say that by 2050 is weigh the part of a different use of current fertilizers and pesticides or different kinds and technological leaps. So each time you need to look at the detail in order to see what the impact is going to be by 2050, and in particular what the impact is going to be on CO2, on greenhouse gas emissions. Waste, food waste. Why assume that you need to improve yields in order to satisfy demand, given that 30% of food produced is actually wasted? Okay, we're going to try and stay entirely calm here. Waste, no, very good question. So, of course, you can act on food security if you can use it as a driver in order to reduce waste. Work is being done in order to see what drivers we could use in order to reduce waste. Some work is done on public policies, on production methods, and on use. It's not easy because this means a change in habits, but again, in our equations, we assumed that waste would not be reduced and it would represent a stable share. Now, in this study, we did not take into account the behavior of stakeholders, and so we didn't make a calculation to see how yield should be changed or should improve if we want to respond to current demand. Okay, this 30% of waste is a complicated figure, actually. It's tricky to handle. Why? Because it's taking into account the entire waste down to what's happening in the household. So this is part of our diets. And so you can have a waste of kilocalories that can be entirely due to what happens at household level, at the consumer level. Then there's everything from production, transport, and storage. This is waste according to the definition of the FAO, and this is not 30%, and then there's also waste due to loss in yield. And then there are some regions of the world where the use of machines would mechanically drive an increase of the yield. In Africa and Algeria, if you change all the machinery, the yield would actually be multiplied by 2 because half of the harvest is lost due to technological factors. Question here in the audience? And don't worry, microphones will go around, so please, even if you're seated at the back of the room. Xavier Poux, ASCA, I'm associate researcher at INRAE. So, the title of the conference was What Role for European Agricultures in the World on the 2050 Horizon? So I don't remember seeing charts addressing directly the question. Now, if I base myself on my knowledge of the role of Europe in global food security, it is actually negligible. So, if we're highlighting production in Europe, basically we're taking into account a variable that is certainly not a driver for world trends. Now, one conclusion I drew from everything that's been presented is that we give up on production targets, then we act inconsequentially regarding food security in the world. Okay, you're going to accuse me of extrapolation, but isn't that actually the logical conclusion? No. I'm struck by the fact that you have only one set of parameters, high yield, low yield, with no differentiation depending on the world region and with no differentiation depending to technology. It is clear that in regions of the world where there is high demographic pressure, you need to increase the yields. So in Africa, in India, and in Asia, I think there is no other way forward. However, what the model says is that if you increase production in these regions, then the collateral is that you need to increase production in Europe. And here I find there's somewhat of a blind spot in the hypothesis that you have chosen. Now, if I'm putting the question to you, is that the increase of production in Europe, well, it's problematic because the charts are showing that there's a problem regarding sustainability and that our production actually is stagnating in Europe. Now, if you're talking about fertilizers and pesticides with the effect on the soils that we know, and these are again things that you do not take fully into account in your analysis. Bertrand is going to answer that. Okay, Xavier, contrary to what you stated, there is no parallel trend in this study for all world regions. No, there are trends with a low yield scenario and with a high yield scenario, and there is a differentiation depending on the world region. So I beg to differ here. Now, in our hypothesis, the increase for European production is 20%, where it is 100% for Africa. So this is really important. So no, we haven't assumed that yields are going to progress at the same pace in every region of the world. That is not what we did at all. So we based ourselves on FAO data for low yields in the regions, and the increase of yield in those regions was much higher, so 100% for Africa. However, the starting point in Africa is very low, and even if you double it, you have still low yields. And so the greatest gap between low and high yield is actually to be found for the ex-Soviet Union. Now there, in the past, there were very small gains in yields, and we assumed that there would be enormous gains. Okay, now, your argument that we're not addressing the role of European agriculture in the world. Okay, this is a relevant question. Yes, you're right to point out that Europe is playing a marginal role. It's a small region. Yes, we know that. If you look at the outcomes of the study, is that our competitor is the former Soviet Union. Why? Because the land surplus in the former Soviet Union is high or very high. And so here, there is a lot at stake for food security in the world. Yes, Europe is playing a marginal role, and this is why we do not actually look at how European surplus could be mobilized in order to address the demand in Africa. No, we looked at Brazil and Argentina with the hypothesis of protein autonomy in this region. And we also looked at what could be done in order to reduce intensification. So yes, those are typically European questions, but in order to do that, we had to place Europe within world trends, and we had to highlight that other regions other than Europe could actually have a great role. So I think this is actually an opportunity for rich debate, and we will be able to carry on at lunch. So in order to have enough time for lunch, I would actually suggest to bring our Q&A session to an end and to welcome Aline Monnier. Aline Monnier, could you please take the floor?
Aline Monnier, où est-ce que vous vous mettez? Si vous vous mettez au... Voilà, c'est parfait.
Vous me dites c'est peut-être mieux là. Alors,
je vais vous présenter Aline Monnier, vous êtes la directrice.
So Aline Monnier is the scientific director of the FABLE Consortium. It's an international consortium. It's a network of scientific institutions active in 20 countries of the North and the South. And the goal of this consortium is to design pathways to 2050 on this very topic, land and food. So this is right in the thick of things. It's a private institution that is headed by an NGO, the Sustainable Development Solutions Network, and IIASA, International Institute for Applied Analysis of Systems, which is based in Vienna. Thank you for this introduction. Thanks for inviting me. It's a real luxury or privilege to discuss the aspects that I found the most interesting in this study. It's like un certain regard, the official selection. I hope I'll be up to scratch. I take this opportunity to congratulate the authors of this work. It's a very rich body of work, and I really urge you to look at the details because the authors have raised many, many questions. Not all of them were discussed this morning, but I think it might answer some of the questions that you have. So let's start by taking a look at the result. The first very interesting result, in my opinion, is the change in acreage under cultivation between 2010 and 2050 that you computed. These results were put forth several times, but there's an increase, trend to increase acreage under cultivation at global level. We have pressure in Africa, India, Latin America, the rest of Asia and Australia, and a reduction of acreage under cultivations in USSR, Europe, and China, and other regions, contrasting regions, based on the results, based on the scenarios used. There's also, they match the results, some of the results of our modelization work with FABLE. So I want you to compare the results that we had last year with the results under your various scenarios. So we're in agreement for the projection in Africa and Europe. In Africa, there will be the highest amount, the highest increase of acreage in the future, and in Europe, a reduction of acreage under cultivations. However, we have divergences. I think they're interesting because they reflect the different assumptions we used. So let me draw your attention on what these scenarios are. I mean, I hear trend-based scenarios, but however, there are significant changes with diets and technological change. So your scenario based on healthy diets and high yields are very close to the sustainable scenarios, SSB1, that we have in other prospective exercises. In FABLE, we also have sustainable development paths that are fairly optimistic, but we see that the results in terms of change of land use stands between your optimistic scenario and your pessimistic scenario. So we have a zero sum at global level by 2050. So now for the divergence. Well, there's India. In India, you see an expansion of land under cultivation under all scenarios, whereas our team found reduction of acreage under cultivation in India, and this is based on an assumption of a significant increase of cultivation intensity that can be an important factor in regions such as India. And also assumptions, more optimistic assumptions on productivity. Then there's the former USSR. You mentioned this on sensitivity studies. Well, actually, the team that worked on Russia in FABLE doesn't foresee a reduction in acreage because it assumes that these areas will be used to increase exports. For China, we also see a significant reduction of acreage under cultivation in your more positive scenarios. But in our case, we do not see this reduction. But that's by construct, because the Chinese team considered that politically there's a will to not reduce acreage under cultivation below the current levels. So that shows that the underlying assumptions of scenarios have a large impact. Now, your work on the use of surplus land in Europe in 2050, I found that very interesting. because it requires to answer the question, what are the goals of the European agricultural systems after 2050? Based on your vision, it's more to first meet domestic demand for agricultural products, and number two, maintaining Europe's position on global markets, and number three only, meet societal goals, reducing inputs and supplying ecosystem services. Well, there are other European studies. There was one in 2018 on an agroecological vision of Europe, with very clearly defined objectives, focusing much more on environmental aspects. There was also the need to meet the domestic food needs, but also a strong focus on biodiversity and fighting climate change. So the goals of European agricultural systems are multiple, and it's a very good thing to have different studies that have different priorities and lead to different results. But so here, environmental objectives are not clearly the priority. So I think this is something you have to bear in mind when you read this work. But also, there's a lot of potential to combine all of this with emission analysis and all this. That could be fairly simple to address these failures, so to speak. So there are three potential uses of land surpluses in Europe. First, increasing European production to increase exports towards sub-Saharan Africa. Second, developing oilseed production to reduce imports. And the third aspect is to combine the use of surplus land and reducing yields in order to keep inputs and trade levels. So by combining these three scenarios, one of the results of the first point is a reduction of twofold of the expansion of land in Africa. So that's a very strong impact. The second is a substitution of oilseed imports. We could substitute maybe 100% of our imports. That's a very important, interesting result. And I think it's also interesting to see the localization of the extension of soybean production areas that could be, according to your study, mostly in Eastern Europe and in Poland. So some potential for those countries by 2050. For the third aspect, you computed that we could reduce or maybe limit the crop yield increase to only 12% compared to today. So it's not a very large increase, but studies such as IFPRI's study had banked on a reduction of yields. And that was a deliberate choice. And I think it would be interesting to compare these figures in future. That increase is linked to a reduction of synthetic inputs, but it's not very explicitly stated. There's a surplus, a land surplus in some areas that's translated in higher yields. But not necessarily the most intensive areas, Eastern Europe, Poland. So in what measure would this translate into a reduction of synthetic inputs? Well, I think that needs to be explored further. And next, for those three scenarios, it's interesting to see what would be the economic implications of all these uses, and also in what circumstances the use of these European land surplus could occur. The case of soybeans is interesting. We have agricultural large power countries exporting countries that are very competitive, such as Argentina and Brazil. How could Europe become as competitive as those countries without additional costs, including for animal feed in Europe? These are questions that will need to be further explored. Now, let us focus on the assumption of this work, the change of the main parameters of the model. So the key is that there's a strong aspect is the change in diets. Now, for the result is quite commonly found in prospective literature. It's a scenario that we almost systematically see in all the sustainable development scenarios with a very strong impact every time. But what I found very interesting is the construct of these healthy diets. You used assumptions that had done for INRA and CIRAD 2018 and the WHO recommendations. There's a study of Lancet, the Lancet that was widely commented with average recommendations per category to reach, to have a healthier diet. And by comparing the two averages, I balanced out. I computed the mean. There's a min and a max for each category. There's the level of calorie intake is slightly higher than the Eat Lancet recommendations, but the main differences are found in animal products. Your healthy diet includes consumption of animal products that's higher than the one at Eat Lancet. And the Eat Lancet scenario focuses a lot on nuts and almonds and all of that, which isn't mentioned in your study. I don't think it's important, but I just found it, I think it's worth mentioning. Now, the disparity of your diets by region across scenarios is quite difficult to read because there's a lot of information on this slide. But I think I would maybe qualify your conclusions because actually, yes, indeed, there's some heterogeneity, but the heterogeneity is mostly found on the starting situation in 2010, but the healthy diet is very similar across region. So my question is, how does this healthy diet unfold for each product? And there's another aspect that I found interesting is Africa, where the food needs are crucial. And there's the category of others that's very important today. In the healthy diet, it's very, very small. So what does that other category contain? Is it potatoes? And so it's not explicitly stated. So maybe this would require some further explanation. Another aspect, key aspect of the study is the assumptions in crop yield changes. So you had done a much wider reaching study on the crops. There are two types of climate change scenarios with the benefiting from CO2. Then you only keep CPR6 for climate change. You explained why this morning, but you differentiated in the case of high crop yields. You have a full benefit from CO2. Low crop yields, no benefit from CO2. So that can be arguable, but that's your choice. For technical progress, you based your work on the FAO's reports. So there's a strong reliance on past changes. You used previous trends and previous growth rates. There are no explicit data on a projection of fodder yield and the farmland. So this underlies the need for data that you mentioned this morning. So in terms of climate change, it's an econometric model that you use based on a meta-analysis. There's no special differentiation between regions, and there's few data and few different crops. So for climate change, my question is, why didn't you use the EasyMeet data? Or maybe you did use it. It's an open database, and it includes estimates of several crop models with that could maybe enrich your model, maybe if you haven't done that yet. And also you overlay the explicit, spatially explicit aspect of climate change with the current production areas. Now, there's the lack of data on permanent grassland. That's a problem we have in all the other models, actually, and it has large impacts on the expansion of grazeland in the future. You haven't presented these results this morning, but I think that they vary significantly. And my question is, who's working on that? Do we have people working on that today? Because there's a lack of data on this, increasing the share of this permanent grassland that is used, that is unused, and that really has major consequences on the land use change in the future.
Les évolutions
Now, regarding the impact of technological change, now that is a graph that is showing the difference according to each region in the case of low yield or high yield. These are projections based on FAO work. In some regions, there is no difference, whereas in others, yield is progressing rapidly. And so I agree with what has been said this morning. Now, the FAO is basing itself on a number of experts, but we do not know exactly how the calculations are made. So when there are small differences, is it because there's a high level of certainty regarding the yields? I'm not sure that's right, because this has will have a strong impact on the calculation of land surplus in some regions and in others. So I think that we need to take a close look at those hypotheses. And we need also to wonder how we can have better working methods in order to project by 2050. So should we actually have simplified production models taking into account inputs and technological change? Should one carry out a wider consultation with experts for certain key products or certain key crops? I'd be curious to know what you have to say regarding this. Now, regarding cattle farming, I felt that this was really a very interesting part of the study, and that some innovations were of particular interest. Now, regarding other prospective studies, this is, it seems, major progress. Of course, there's still a need to aggregate data, but clearly we have moved a step forward, or you have moved a step forward. Now, for example, you take into account the impact on climate change on animal feed, and your world model of calories or input of calories is also something that I find very interesting. Now, something else that is not obvious in many models and that I find really interesting, but again, you base yourself on the FAO and on studies published in 2018 for your cultural intensity calculation. Well, I'm not familiar with that particular field, but cultural intensity reached the highest ratio in Europe. To me, it's not very clear how this calculation has been made and why Europe is such a forerunner in this area. And then there is also the question, there's the link between climate change and the number of harvests.
Des écarts, en tout cas en Europe, entre ces intensités.
And then there's also the fallout that plays a role in something that you should look into.
Ma question est...
Now the fallows should also be taken into account. Now, you mentioned the GAEZ maps, the GAEZ maps, and I think that you kind of made a calculation for the total cropland, or did you actually make calculations based on individual crops? Of course, the effects of climate change vary depending on which crop we're talking about. And then there's also a spatial dimension, something that may actually allow you to improve your results by having, for example, gaps depending on possible improvement based on environmentally friendly agricultural practice, and so there you could maybe make a calculation on which zones are more conducive to cultivating some crops. My final point is regarding the trends in international trade, and above your results depend, of course, on how the model is constructed. I would not give too much credit to the results that are based on international trade parameters. The model is very transparent. For example, you have constant shares in exports and imports. You have also share that stable share of domestic consumption, and calculations also made depending on the available land. But I really have the impression that here projections are based mostly on historical trends, and it is true here that an analysis of the sensitivity of these parameters could be useful. Maybe you could actually go into depth in order to improve, for example, the cost of transport, trends in tariffs, etc. Thank you very much for your attention.
Merci Aline Monnier.
Thank you very much, Aline Monnier. So, Aline, thank you very much. I'm here acting as a spokesperson for the entire team. Thank you very much for this highly interesting feedback. Notice your look on our study was really highly valuable. Unfortunately, we cannot actually launch a discussion right now because it is nearly time for the lunch break, but I would really like a discussion, and what I found of particular interest is that Aline pointed towards elements that we did not have time to present. For example, she mentioned the tests that we carried out on trend-based in the aggravated scenario, so she mentioned that. Then there's also the land availability constraint that we mentioned, taking into account the area dedicated to forestry. So I think actually, Aline, that this is going to, it's an invitation to look at the detail of the report. Bertrand, a word? Thank you very much. You really had an excellent reading of our study, and Anaïs is right. It is something that actually is an invitation to look at the detail before tearing the building apart. So you pointed out the differences between India and China. Now, I did highlight the fact that China is a particular case, and there is a footnote that is making another calculation in the case where China is using its available land in order to reduce its imports. Now, this is in a scenario with high yield and healthy diet, and there China becomes a net exporter. So you really need to actually go into the detail of the ex post calculations in order to have the full extent. And then the last point you made seems particularly relevant. You highlighted the parameters linked to international trade. We challenged them, and we limited the constraint in available land. Now, you're right. The only region where this constraint is available are the MENA region. If you subtract zones dedicated to forestry and potentially urbanized areas, then you only have India and the rest of Asia that has actually a very limited wiggle room regarding extra land. So this is why we chose the hypothesis of stable acreage between 2010 and 2050. And you are right, there is a need in a phenomenal increase in international trade in order to meet the demand of certain countries. So there is actually something on international trade that is addressing the question. Mr. Guillaumard, well, first of all, Thank you very much. Really. It's a wholehearted thank you. Then modelization of imports and exports, even in economic models, is something that's particularly tricky. Now, in every economic study, it is something that poses particular difficulties. And then the third point is the environment. Beyond what we have talked about this morning, there is also a technical report and annexes that show what work has been done regarding adjustments. Now, adjustments in order to reduce the environmental impact. So again, please look at the detail. But what is particularly difficult is to carry out the same analysis, to apply the same methods to all regions of the world. This is why we paid particular attention to the environmental aspect, which is how can we prevent deforestation because of its huge environmental impact. So yes, it is true that for an economist this actually would be unsatisfactory, but we did take into account the factor. And again, I mean, there are economists here in the audience and also in our team, but we would be very keen to have the data for all regions of the world so that we could further our study. If we don't have the data, then we need to have hypotheses. I think that actually data is going to be improved, but this is a collective effort, so I'm optimistic. Aline Monnier, you're going to address us again in the afternoon and open new perspectives. Now, I have a few very important messages. What is going to happen for lunch? So first of all, you need to know that it's on the second floor. Now, for safety reasons, we are going to limit ourselves to several groups of 50 participants. We will be welcomed and guided by staff of our host, the MGEN. Now, coffee will not be on the second floor, but coffee will actually be served here downstairs in front of the auditorium. So as soon as 2 p.m., please move downstairs in order to be able to have time for some coffee and be in the auditorium to resume work at 2:30. And then Kim Girard, you will recognize her, is here to actually distribute tickets, lunch tickets, lunch vouchers. And so in case you don't have your lunch voucher, please do not forget to ask Kim. Now, in the afternoon, we'll have a round table with cooperatives, representative from Carrefour, someone from WWF, etc. So an exciting afternoon ahead of us. Thank you.